Hi John, this is Thomas Hanaho. This is my screencast recording for the team project for CA2 multiplayer distributed programming. So yeah, I should show you. So this is I'll just load up the final game for you. So we have movement down. I can shoot with a bullet. The bullets go the same direction at the same time. Collisions work. That there's only one thing, or all the collisions work in the game. And if you bounce into this building, you'll be pushed back. And then we have win-lose logic here. That if you go into here, if you hit the nuke, you lose. And that's our game. Yeah. So team was the way this screencast is going to go is that I'll just run through this very quick because I think I have 15 minutes. I might have to make 2 videos because 1 minute is already gone. But so the way the screencast is going to go is structured from different things that you said over the last few weeks. So first off, I'll introduce the team. The team was myself, Patrick, and Zelen. The work that each individual did was Patrick did we all worked on the coding. I want to point out the amount of work that Patrick did on this document here. A few weeks ago, Patrick went through pretty much every single file, or CPP file and HPP, and decoded it and tried to figure out what the structure of each thing was. It took him about a week, and it was a huge amount of work. So, I just want to point that out because that was really brilliant. Zelen, really, not pulled his weight, but he came through with the networking part of it. I was really glad about that when we presented on Thursday. The networking at that point, it was like non-existent, and he just came in and it was working to an extent that you could get multiple people on the server at the same time. So yeah, that was really good as well. Myself, I worked on the code mostly, trying to do as much code as I could in the time that we had. Just because I knew I wanted to learn as much of the code as I could possibly. So I focused on the collisions and I focused on player movement, as well as just fixing general bugs over the course of a few days. As well as that, I worked on the networking theory. So I went through the notes in the PowerPoint, and I went through each of these and read through them and sort of tried to understand it as best I could, and then I relayed that back to the team as well, because they were working away in the code, and I thought, yeah, it's a team effort. Overall, I really enjoyed working with the team. I think they're a really good, hard-working team to work with. But anyway, so I'll get into it because I've got how many minutes left. So overall, I'm glad with the progress that we made comparing it to, I think, Wednesday when we saw you. I think the reason I was so sort of stressed out about it was that I was worried that if this right now I'm bridging, counting all of I'm averaging 69 overall for all the modules that are sort of done from last semester. So I was really worried that if I had failed this module, that it would bring me down to a 2-2, which would be heartbreaking. But I hopefully now we'll be able to pull through, and the plan is now that just get as much point as I can with this, and then sort of recover with some of the other modules that I find sort of easier. And thanks very much for the help as well on the other day. Like I don't know what it was, but as soon as you sort of showed me the process of sort of looking through the code and finding all the references, that it worked really, really well. And it just worked super well. Anyway, so I'll go and then my own abilities, my own failings, then I think my coding, definitely finding my way around the code and the actual coding, figuring out problems, has improved over the last few days. My understanding of the networking stuff has definitely improved. I definitely know the difference between the the client and server, and definitely UDP and TCP, which I'll show you now. And then in terms of failings, I think I had a bit of a crash on Thursday where I just came home after that day and I was just completely mentally and emotionally drained, and it took me out of it for about 2 days, Thursday and Friday, and a little bit of Saturday morning. So I think one of my failings would be that I sort of need to maybe limit myself. No, well, not limit myself, but maybe focus on my endurance more when doing these sort of long hours instead of, and maybe sort of pacing myself more. I think, definitely one of the failings of this module was that I didn't really give myself enough time to study it last semester due to team project. So anyway, that's all of that sort of initial stuff done. So I'll get back right into it. So to start off, straight away, the difference between, there's two different network protocols that you can use. One is TCP and one is UDP. So I'm just going to talk go through this relatively fast because I don't want to be wasting all your time. So in the TCP, the packets will be received in the same order that they were sent. The packets will be split if needed, and the connections are made when one of the computers enters a listening state on the port and another uses TCP socket to connect to the port. I'll show you that now. So this is here. So this is setting up the socket in the multiplayer game state. So this will set up the socket which will allow and set up the socket which will allow the connections to happen, and then this sets up the listener. So when this is set up now, this is telling the game server to listen for connections to happen. TCP is very reliable, but it was also very bulky, so it's not suited for this sort of game development. What you would want to use is a UDP. So the difference is that the data may get there and may not get there. The overhead is a lot lower. I think it's only over 8 bytes or whatever, and there is no overhead ensuring that the packet will get there, and the packet will not be split. So all packet management has to be done in before the packet is sent. The data is packed into a byte array. So that's just the initial done. So overview of the client is the client server is the standard for the multiplayer games programming. It is heavy on the processor. However, the advantages of this is that it has complete control over people cheating. Whereas if you were to not do most of the processing on the server side, it would be a lot easier for people to cheat by sending up their own sort of data, saying that they had health of like plus 100 or something like that. So the multiplayer game state is the client side of the game server. On the multiplayer game state is the client side, and the game server is the server side. Sorry. So yep, here it is. So how the program works is that it will first, when the multiplayer game state is being initialized, it will require you to input whether the multiplayer is a host or not. So this is where the states whether the game is a host or not. So if this section here will decide what you're going to do with the multiplayer game state, depending on whether you're a host or not. So if you are a host, then you're going to set up a game server, which is here, and then you're going to set your IP to the standard IP. Otherwise, you're not going to set up the game server because you're not hosting it, and you're just going to ask the IP to get the IP from the file. So that's where those IPs from the IP.file is coming from. The IP is, or the host is launched in a constructor and shut down in the destructor. Okay, so right now I'll give an overview of the multiplayer game state. So this here will just get the address from the file base, which is called from here. So at this point, this is the understory method. So when this happens, is if the multiplayer game state is not a host and is still connected, then you're going to destroy the player from the network. The update is used. Where's the update? This is used to just sort of remove players from the aircraft when they're destroyed and do other things like that. And then on hello return input if the window focuses on the game unpaused. Yep. The update will handle all the functions, all the methods that are used in the update game state. It goes through the packets and things like that. Yeah, regular position updates. Okay, handle events. Sorry, lost my train of thought there. So the handle event method will take in an event and output a result as that. So for the first thing here, it says it will take an event, and if the event is key pressed, then it will do the action based on that. So then the enter key pressed second player co-op. So in this instance, it will add another player to the co-op, and then it will create a packet, and then it will make take a request, which is one of the protocols, which is request protocol or request co-op partner, add that into the packet, and send the packet under the server. It also gain focus, lost focus. I'll be honest, I'm not completely sure what those are for. Yeah. And then the last thing is handle packets. So, yes, this is where all the protocols are for. So in this instance, whenever this is where all the packets will go. So when you get a new packet, it will be sent to handle input, and then there's a simple switch which will take in the packet type, and based on which packet type, it will do something else. So let me think of a broadcast message is a fairly simple one. So will just declare a string called message, and then you'll take the message, take the string from the packet, and push it into end of broadcast, which will probably output it to the file. Excuse me. Let me see. The player disconnect is an interesting one. So when the game server sends the packet over to the multiplayer game state, it will say that it's a player disconnect. So then what it will do, it will send over the aircraft identifier, and then, it will create an aircraft identifier, and then it will take this from the packet, and then it will say world.remove this aircraft. So this is when the player is disconnected. So the protocols will be talked about later on as well. So that's just an overview of what the multiplayer game state does. So now onto the game server. So the game server is run on a separate thread so that it can call blocking calls and the game can run smoothly. So if the game server didn't run on a separate thread to the main process, then what would happen was that it wouldn't have independent sort of features of the thing. Of the game, and then if it didn't have an independent processes, it would slow up the. Yeah, it would slow up because it would have to handle a lot of all the other processes that come with running the game on the PC, like just the general like clock and stuff like that. Whereas this way it has its own dedicated sort of process, and it can sort of stop and start whenever it needs to. Execution thread. Okay, let's see what this. So now we're into the game server. So the execution thread is the method that will start the game server. So this starts the game server thread if necessary. So it will ask if this game server needs to be started, and then if it does, it will start it. So the first thing that it does is it will start a listener. Execution will start the thread. There are three main steps to the start server thread: initialization, loop, and termination. So here is the initialization part of it. So when the server starts, the TCP listener will start. And actually, I'm just about to run out of time. So what I'm going to do is I'm going to upload this one to YouTube, send you the link, and then I'll make another